Alrighty, physics, and we're going to do unit conversion 3. Here, we're going to go a little bit beyond what we've been doing, and we're going to do these conversions in the context of an equation. And I'm going to show you what derived units means, what that is. First of all, let's look here. Okay, force equals mass times acceleration. It's one of Newton's laws. I think it's the second law, but I'm not sure. What we're going to do is we've got an equation where, let's start here. Let's start with the easier ones, where you're given the mass and the acceleration, and you want to solve for F, okay? Well, it's 28 kilograms over times meters per second squared. First of all, you need to understand that one Newton is 1 kilogram times meter per second squared. That is what a Newton is. A Newton is a derived unit. It's a composite of others. Now, you see how mass and acceleration are multiplied together? That means you can just move straight across on your conversion chart, okay? You've got 28 kilograms, and then you've got 14 meters per second squared. And you're multiplying, so just put them beside each other. And obviously the second square goes on the bottom. So 28 kilograms, so we're going to do that. We're going to do 28 times 14. Well, okay, forgive me, 14 squared is 196. 196 times 2 is 384. No, 392. 392. So this is 392 newtons. Now, if we want to do this correctly, there's only two significant figures here and here. So this becomes 390 newtons. And then we can go ahead and collapse that down to 3.9 times 10 to the 2 newtons. Okay, and let's do one more like that, just to get you used to it. Again, we're going to solve for F. Same thing. Let's make the numbers a little bit different. Make this 13 and 20. Okay, so what you do, you set it up, and it's going here and here, they're being multiplied, so just put them right next to each other. 13 kilograms, 14 meters per second squared. Oh, pardon me, sorry, 13 and 20. See, even teachers make mistakes, all right? Don't let any teacher tell you they don't make mistakes. So that's going to be 260 newtons. And here, actually, you've only got one. So we're going to make this 300 newtons, or 3 times 10 to the second newtons. Okay, with me so far? So that's your force. F equals, that's your force. Force is in newtons. Okay, let's do one where, hey, look, we've got to solve for mass here. Well, okay, let's do the literal equation first and solve for mass. Obviously, divide by A here and here. And so mass equals force divided by acceleration, which means acceleration is going to be in the bottom, okay? So let's do this. Now my force will go up top, 320 newtons. And let's go ahead and write it out completely. 320 kilograms times meter per second squared. Now, the mass, pardon me, I want the mass, the acceleration is going to go on the bottom, 2.5 meters, and then the second squared would go up top. All right, because, you know, top, bottom, bottom, top. All right, they have to be opposite each other. Cancel out, and you get 320 times 2.5. Well, 640 and 1/6 should be 700, but let me get a calculator just to be sure. 320 times 2.5. 800. Good thing I looked it up. 800. So now how many? We've got two significant digits, so we can just go with the 800. So it's going to be 8.0 times 10 to the second kilograms. All right, next one. Different equation, E equals mc squared. What does energy equal? Well, let's do the unit analysis and see what we come up with. All right, here we go. Energy, we're going to solve here for E, and you'll see what we come up with. So a mass, now in E equals mc squared, C is the speed of light, and this is the speed of light in meters per second. All right, so, and they're beside each other, so you can move them right across. So 15 kilograms, and then it's C squared, so C twice, so 3.0 times 10 to the 8th meters per second, and then another one. There's a different way to do this, but I'm just being very, very explicit here. 3 times 10 to the 8th meters per second. Okay, so what that is 15 times 3, just 45 times 3. So 9 times 15, 90, and 45 is 135. So 135 times 10 to the 16th kilograms times meters squared per second squared. So that would be 1.35 times 10 to the 18th kilograms meters. Now, if you remember, a Newton is kilogram times meter per second squared, but here's meter squared. So this is actually a Newton meter, but in physics we call it a joule. Okay. Joule. We'll get to this later. I'm just showing it to you now. So the energy contained in that mass is 1.35 times 10 to the 18th joules. All right. So there's that one. Now, one more example. Oh, two more. Here, this is potential energy. Potential energy is dependent upon the mass of something, the acceleration due to gravity that it experiences, and the height above the ground. So, and potential energy is just like joules. It has to be in kilograms times meters squared per second squared. If one of those is not in the unit it's supposed to be, you've got to change it around. So here, this is all kilograms, meters, second squared, meters. So we're good here. We can just multiply these together. Okay, so 10 kilograms, boom, 9.8 meters per second squared, boom, and then 10 meters. So 9.8 times 10 is 98, 980, so 9.8. And actually, since it's only one significant figure here and here, 98 becomes 100 kilograms meters per second squared, so 100 joules. Okay, that's how this works. It creates a derived unit, a joule, a Newton meter. Come down here, and we have a problem, grams and kilometers. Okay, so in the midst of the problem, we've got to change these to what we want. Okay, well, 600 grams, okay. Tell you what, let's help ourselves out and use scientific notation here. So this is 6 times 10 to the second grams. Now, 1 kilogram is 1 times 10 to the third grams. All right. Now we've converted grams to kilograms. Now I need to convert kilometers to meters. So you've got 1.5 times 10 to the 0, because we're not moving the decimal at all, 10 to the 0 kilometers. And I know that 1 kilometer is 1 times 10 to the third meters. And then you're going to multiply that by 9.8 meters per second squared. Now, let's start canceling. Kilometers are gone. Grams are gone. We've already done that. Now, we have 2, 5, and 3 on the bottom. So that's 10 squared. Oof, that's a horrible, horrible 2. I'm getting better at this, but still. So it's going to be something times 10 to the second. Now let's do it. 6 times 1.5 times 9.8. Okay? $88.2. Now, 2 significant digits. No, 1 significant digit. So 88.2 becomes 90, which is going to be 9 times 10 to the third joules. This is a combination of how unit conversion works and also how you can find so the potential energy here, and also how you can find derived units. Finding derived units, it's a further use of unit conversion. Just got to make sure you're paying attention to where things are supposed to go. All right, that's it for this one. I will see you later.